So now everyone, you can go ahead and click your logic button at the top. Just needed to make sure that you guys saw that you had your temperatures. I had to add mine. Sorry that I came here, but I had to add them in here. I want it to be the same as yours. Okay, so I'm going to go to my logic page. This is a very early intro to logic, of course, when we're doing your system, and guaranteed all day tomorrow, we're going to be in the logic pages, all day tomorrow, okay? So for today, I want to show you. Number one, when you're looking at a logic page, you're going to notice everything on the left side of the screen is information coming in, all right? Everything on the right-hand side of the screen is information going out. If you scroll down, or depending where you're at, it could be chiller start stop. If you notice, I have supply fan start stop here. So that's going out to a relay, okay? Which actually, if I look on my panel, I can see it's turned on now. And then, of course, the status coming from it is here on the left. That's information coming in. So I'm wired to a current sensor. And when I tell the command to turn on and the fan starts, the current sensor senses voltage in the line, and then I get status saying here, yes, the fan has started, all right? But what we're looking for now are the temperatures. You guys just all set up your trends to trend 2 temperatures because we believe that they're all 0 or negative 59, right? So a temperature is what going to a program? Is it coming in or going out? Coming in. So we're going to be looking on the left-hand side of the screen for the 2 temperatures that you added into your trend. Back here, you're going to be scrolling down to the left, looking for 2 inputs that look just like this, by the way. Like I said, I'm going to start mentioning it. This is a charcoal gray hot dog, all right? Anything that's a charcoal gray hot dog indicates that it is a physical point. And so you don't think that I have a whole list of these. There's only 2. It's either charcoal gray or it's brown. If it's brown and it has N in it, it means that it's a network point, which you can see here at the top, all right? So if you look down here, you see these 3 gray hot dogs. This one says BI for binary input. Same thing here. It has a little icon underneath of a set of contacts, all right? This one up here, if you notice, it says ANI, and it has a picture of a thermometer. That's an analog network input. Network inputs are coming from somewhere else in the system. Gray hot dogs are coming from a module. All of you are looking for an input, right? Temperatures are an input, so you know to look down the left side of the screen. The next thing you're looking for is a temperature. A temperature is something that varies. It's not binary. So you're looking for a dark gray hot dog on the left-hand side of your screen that has AI on it for analog input, and it's going to show a little red picture of a thermometer. And that's all that'll really be in there in your systems. I mean, if you start dealing with metering and stuff, we have another hot dog. It shows some purple lines. It's a pulse, but we're not going to deal with pulse. Even if we put a pneumatic module into your system, the pneumatic value is still analog, right? It varies. So we still use an analog input for pneumatics, okay? So once again, these are the 2 hot dogs that you just get to know, and you're going to find them on both the left and the right. Analog and binary values coming in, you know, analog and binary outputs going out, all right? BI for binary, right? If it's on, off. And for the temperatures, we're all looking for AI, analog inputs. Okay? So now what we're going to do is we're going to learn how to lock a point. And here's my mixed air temperature, and here's my return. So I'm going to double click on this hot dog here for my mixed air temp. You're going to click on your chill water supply temp hot dog. And this window is going to come up. Double click, and the window's going to come up. There's a little checkbox where you can put a mark in here, right, for locking it. So I'm going to say, yes, I want to enable a lock. So I'm going to put a check mark. Once I put the lock in, you'll notice that the value now changes from gray to black, saying that it's now editable, and now it's asking me, what do you want to lock it to? Okay, and I'm going to say, fine, I want to lock it to 55. All right, okay, so I'm going to lock this temperature at 55.123. Doesn't matter. Did you notice when I put the 1, 2, 3 and it still kind of shortened it up? It says I'm only going 1. So lock your chill water supply temperature at 55.
I got the check there. So
You got to put the check, and then notice how immediately it came up with those 3 buttons. All right? Okay, cancel, and apply. All right? One of those buttons was purposely put in there for the intention of building engineers. When we first started, we only had 2, okay and cancel. If I hit okay, it's going to apply the value and close the window. If I hit cancel, it's like, well, I wasn't sure what I was doing. It'll just disregard. It'll never write to it. For you guys, they put in the apply saying, you know what, if you're locking something, you're probably just doing some troubleshooting, and you're probably going to want to undo it. So it applies it to the system and keeps the window open for you. So if I'm testing something, I could hit it, it'll stay there, right? Because I could get involved in something really quick if I'm on a building, right? And in case I forget to come back, at least someone else will walk in going, hey, who locked this? See, so it's a great feature to use that apply until you're done with it so that you remember that you've locked something, because there's something to mention about locks. If you lock a fan on, nothing in programming is ever going to turn that off again. If you lock it on, it just stays on, period, that's it. Unless that freestat trips and cuts the power going to that drive, that fan just keeps running. Right? Huh? Or fire alarm. If you lock that off, doesn't matter what the fire system does, it will never come on. All right? If you go in here and you say, okay, I'm going to take the smoke detector and I'm going to lock it off on the air handler, no matter what the smoke detector really sees in the field, you've locked it here. So it's real simple. I have a temperature probe out here. All right? No matter what I do with this probe, it could be like an air handler, I'm locking it at the module, right? So let's just say all the components, the probe, freestats, all those are in the field, right? But all this locking and everything else takes place here. So if this value out in the field can't get through because you've locked something, well, that's where it'll stay. So the smoke detector on the RTU will go off. The smoke system, of course, will still kick in. You're not locking that device. You're just telling your module, you're telling the ALC product, ignore it, is what you're doing. And then the air system won't act according to the way it's supposed to when a fire system, when a fire alarm point goes off.
You have two ways of locking that smoke detector, duct detector though, actually?
I could lock it on or lock it off.
Right, or through the fire panel, bypassing or something like that for testing or,
Testing.
fire testing or.
Well, you just picked the one thing. Now you picked fire systems, and out of everything else, there's one thing to remember about fire systems. We can't write to a fire system, and they will cut off our communication if they have to, because the fire system has to be able to do its thing. So we can't send it anything, we can't tell it anything, we can just listen to it, because we can't interrupt the fire system. But we're always hoping to hear from the fire system, which they test, and they want to make sure, because they're going to say, well, if this fire alarm point goes off on the second floor, then we want all the exhaust fans for the second floor on, but then we want the first and the third floor to start overpressurizing, push all that smoke in the fire to keep it on the second floor, so that's what they want to test. The right exhaust fans go off, the proper air handlers turn off. If you're over, 12,000 CFM on a fan, the fan has to turn off. Is it?
Or the damper has to close.
Or the damper has to close, right. And then if it's under 12,000, then there's another, set of, depends on where it is, what you're trying to do with it, smoke purge. If you have a fire on the floor, it's strange, but we want to open all the outside air dampers on the floor that has the fire. We want to ramp up the exhaust fans. We want to go to full exhaust, full, like outside air, full exhaust. We want to do everything to get that smoke out. You know what I mean? And then the fire system takes care of everything else, putting it out. So there's a lot of things that'll happen, and that's why I'm saying if you lock a point, now when they go do their testing, of course the system isn't going to act accordingly. It's going to say, I don't see that smoke point going off. And that's what's important. So locking is very serious, but it's tremendously valuable when it comes to troubleshooting, because you can put everything else in the current state and check it out. So we've locked one of them. Let's make sure that we can do it again. Let's go ahead and do the other one, which is the return air temp, which will be your chill water supply, your chill water return temperature on there. And we want to make sure it has to be a different value. We don't want to look at a trend and they're sitting on top of each other. So go ahead and lock it at 77. How's that sound? All right, we're going to lock it at 77. Okay, and just for a minute, because I do have a few more things to talk about, we're going to go ahead and let it naturally get a trend, and it's just going to wait. It could have been ready to get one in 2 minutes. It's trending every 5 minutes. So whatever it is we just did, who knows? Maybe it was ready to get one. Maybe it's not. But we do know that for a fact, if we do something for 5 minutes, we're going to see our new point, and when you go to your graphs, you're going to see the new values. So while we're in there, let's go ahead and just talk a little bit more about locking points, all right? If we go to the graphic, just don't move. I'm going to do it, and then you guys just go ahead and look. I'm going to say, you know what? I was just here. My command for my fan says on, my status says off. Now the rest of the system, the valves and everything else, notice that they're at 0. They're not going to do anything until I prove flow, right? I have to prove there's flow, or else it's going to say I have no reason to open up the valve. And this happens once in a great while, where you say, you know what? I know the screen says the command is on and status is off, but I was just by the unit. I could feel the air. It's running, right? So right off the bat, we know one thing, right? Current sensor could be broken, right? Okay, great. We know another thing. We need our valves to open. All right, we got to keep the unit running. You just prove that it's running because you're just standing there. The unit's running, whatever's wrong with the current sensor, somebody has to keep, come out, fix it. But you know that you need to get this air handler running. You have to prove that the fan is running so the rest of the system will act accordingly. So what I'm going to do here is I'm going to use a lock, but more for a long-term reason until I can get somebody in to fix it. Or I'm going to lock it for now and I'm going to go change the current sensor myself. So what I'm going to do is I'm going to come back to my logic page. This is why I said you didn't need to leave. The work you're going to do is in here. And for your chiller, you could lock your status on. So I'm going to go find that fan status, right? And tomorrow we're going to talk about it more. I'm going to point it out again, but notice how I found my section because we break this up into their own little boxes here. So this one is all about the freeze stat. So freeze stat logic's in here. Smoke detectors in here. Supply fan control. This is what I'm looking for. I could see it says command on. All right, but see my status says off. So what do you guys think I'm going to do? I'm going to lock it on. So now I'm going to say I was just there, it's there. I'm going to hit lock. The state I want to lock it, right, is on. And I don't have to hit apply. I can just go right to OK and let it close. All right, gone. And I can come back to my graphic and I can see in a minute, I'm going to see my status. There we go. So now my fan is now getting status. So now, based on my discharge air temperature and my set points, now my program is proving flow. Then my valves are going to start to open to maintain my temperature. So this was a way to utilize a lock as a fix for now, a Band-Aid, if you will, while you're dealing with the problem, okay? So I showed you one where I left the window open, I hit applied, I locked something, I went out into the field to go check it, or I'm standing next to the air handler with my laptop or my tablet, and I check something out and I lock it, okay? This is all part of checkout. And on this one, I say, well, I got to change the current sensor, but in the meantime, I could go ahead and get this air running, get some cool air going, knowing, of course, that you have to stop a fan to change the current sensor, right? We don't change those live. Real quick, this is just a quick check to see where we're at. Would you lock off a supply fan if you wanted to go work on the fan? Huh? You would lock it off using our software to go into the fan, right? Okay, right? You cannot trust that output. Anything could short that. All we do on our output side is we're just taking, if you look at it really close, whatever's on the first screw, each output has 2 screws. And whatever we put on the first screw, usually 24 volts, when we do a dry contact, that's what comes out the second screw, right? So like if you come through all of our outputs, you'll see there's like a daisy chain of power. We send 24 volts on every in, and then whichever relay we want to turn on, that comes on the output. But anything could short those screws. So we do not use the ALC system. You can lock it off, and that's fine. Go into the system, say I'm going to work on the fan. You can lock it off, right? And I have reasons for this. I'll lock it off, then I'll go to the unit, hit the disconnect, then lock out, tag out, right? And then let everybody know. Because I want someone else just by chance to see it, or in case they come into software and they do something else. Somebody could change something at any second, right? Do not use the system for safety. Excellent. So now we locked our points. Now we've had enough time. Let's go ahead and take a look at our trends. And then we're going to go on to, because we're going to notice that the outside air dampers have opened, but my chill water valve still has not. But right now, let's go to our trends. Okay. We're going to go to view. Well, you'll be on view anyway. And I have my 2 temperatures, the same ones that you guys just locked are on my graph. All of you have those two values that you've just locked on your trend. Right? We all just hit it at the same time, so now that my server's trying to answer everyone's question at the same time.
Gym part again?
Yeah, it's going to come in. See, so now I have some new values down there.
Oh, that's not coming up.
It will now. It's going to start answering everyone's question. All right, you should already have those temperatures in there. So now, we just did it, right? How much time am I looking at on this graph? How much time? 1 day. I'm not sure. I'm going to verify that I am. I'm going to real quick, and you may not want to do this like right now because everybody's trying to update, and my computer's a little tired, kind of like me. But I just come here under the configure, and I'm saying always by default show me like 1 day. So let's just say I want to see 2 hours. Okay, you don't have to do this. Now, just by default, it's going to resize. I could always scroll. I could zoom out farther. All that wants to know is it says each time you come here, Should I try to show you a full day, or would you like just to see the last couple hours? Usually people set up just for a couple hours. Right. Okay, see, so now you can see these two values, right? One of them I locked at 55, one I locked at 77, right? And if I wanted to, I could do a right click. Oop. Here, let me reset that, grab into here, and now I'm gonna hit auto update. So now that auto appears, and every time a new point comes in, that's gonna keep changing, all right? And you'll see the next batch come in, next batch. So I'm gonna walk around and help you guys out, all right? Okay. All right, so now if I wanted to, of course, I could go back in, I go to my logic page, and I can go and I can lock these at different values again. So now I'm gonna change my mixed air temp. Let's go ahead, so now I'm gonna cut it in half, so I got 50, I'm gonna make it 25. All right. Notice I didn't have to change the lock. I didn't have to do anything. I just went in and typed a new value. I could see the lock is there. So I just went in and I hit it at 25. I'm going to do the same again. I'm going to open up the other micro block. I'm going to see that there's already a lock. There's no reason to put another one in. And, you know, here, I'm going to cut it in half. I'm going to make this like here 40.
That's a cold fan.
That's a cold fan. Of course, in there, of course, I'm going to start getting alarms, and my dampers are going to start getting affected. And right now, I just want to make sure that we're comfortable with that lock, because when we start looking at your system, we're going to go through the programs. We had enough time last time in that one day to go through VAV boxes, go through your chiller, go through your boiler, and seeing where and why we would lock points. We're going to talk about this a lot. You're going to spend a lot of time in here. Okay. So then I turn around and I say, well, you know what, here, I like this trend. I see the way it's working. I like the graph that it's on. It's giving me the values that I want. I've already decided to set it up by default as 2 hours instead of an entire day. Okay? And then, of course, what you should be able to do then is turn around and say, you know what, I want to check on this fan. And you should be able to, by now, I mean, like right now, as soon as I'm done, you guys should be able to do this just like that. Go to configure. Say, you know what, I'm going to add a new graph, and my graph is going to be my fan and status. There you go. I'm going to add to. I'm going to add here. I got to add this supply fan start stop. Click add. I'm going to do status, right? I'm going to say OK and come back and find out I have a new graph with supply fan start and stop. Right? You should be able to click into it right now. Go to your trend. You're viewing it. Click the tab that says configure and add 2 more points. You should be able to do that in literally in less than 30 seconds. Done. Excellent. Done. Add a graph. You have to add a point. There you go. See, because you clicked the point first. Now go ahead and click it again. All right. Now add another point. There you go. You got it. You have to hit add first and then add your point. How are we doing over here? You're adding in your graph. You got supply fan start stop in there, right? I think it's on the wrong graph, though. I think you needed to make a new graph. That's it. I got to take cards away. Right? You're adding it in. There you go. Got your graph down there. Right? You go in, you add a graph, then you have to push the button that says add a point, then click the point. Add a point, click the point. So once again, we're going to go back to our graphics, right? I can see, you know, I see that my start, stop, and status, you know, whatever my points are doing here. All right? What we want to do is we're going to go back to our graphics. We're going to take a look, and we're going to say, well, I see a few things wrong here. Right? So technically, right now, because we're learning about locking points, and we know that we can do it now, we could say, well, here, I need to make this air handler work the way that it should, right? And what we're going to do is that when we get back from our break, that's what we're going to do with this commercial break. All right, so we want to get back to our points here. So I said that we're all going to work on our gym air handler, all right? And we want to get this air handler to start working right. Now, this would be the same thing that we would do if you had a live system, right? And something's going wrong, you want to check, you want to see how it's reacting. So what we're doing, even though we're doing it on this gym air handler that's on this module, there is nothing different, and there won't be. The logic even looks the same. And I'm going to show you how. I told you guys that all of you in this room are going to write a chiller program in less than 30 seconds, and you're going to spend an extra 5 seconds making a graphic for it, and each one of you are going to have this done. All right? It doesn't matter. The programs come from the same places. All right? So it's going to look exactly the same. So we're going to set this air handler up on our screen so that when we look at it, it looks right, the way that an air handler should be running, right? We're going to have a return temperature around 72. We're going to have a discharge of like 55, all right? we're going to get all this working. Our outside air dampers should be 20% open unless we're doing return CO2. We're not, so we have to go to a 20% minimum on our outside air, all right? So let's go ahead and start going through it. So now we're going to start learning again about locking points or whatever. And then when we're done, keep in mind all of our points that are trending. When we pull our trend, we're going to start to see the trend start to react the way that it should. All right? So let's go ahead and go through the steps. All right? First things first, I start coming in here, and I can just say, you know, I'm going to start going from the return all the way through my system. All right? So my return temperature, is 40 a good number? No. Now I'm going to show you a shortcut. You don't need to remember this. You could always go back to the logic page. I'm going to do this twice, and then the rest of the time I'm going to go to the logic page. If I hold down my control key, because there's two keys I could do here, and depending on which key I hit, I'll get a different response. If I hold my control key down, and I click on my return temp, it's going to give me a window which is a direct link to the exact microblock that it's coming from. I don't have to go looking for it, right? I don't have to say, oh God, what did he say? Everything on the left is all the outputs, everything on the right is all the inputs. No. Everything on the left is inputs. You see what I mean? So you could either do the control and click on it. That will get me the microblock. If I hold down my Alt key and I click on it, then I get the global modify window saying, okay, well, here, now I'm going to go and I'm going to go say here, now check every building in here, find any unit that's using the program RTU and tell me what its return air temperature is. See, so right now I could go through and I could find the return air temp of everybody's air handler right now in this building, all right? So that's the global. So once again, I'm going to go back. What is a normal return temp that I expect to see? 70s, right? Let's grab like 71, 72. You go ahead, but it's going to be like in the low 70s. I'm going to say mine is 70.12. Okay?
So you want to leave it locked?
I want to leave it locked, and I'm going to hit OK, and I'm going to close it. We're going to get all these numbers on this screen to look right. Okay? Because I may have a bad return air temperature on one of your air handlers or your RTU. And I'm going to show you in logic that if your return air temperature isn't working or it breaks and it reads negative, it forces our software freeze safety to kick in, and it closes your dampers and it opens your valves halfway. All right? So you will be doing the exact same thing that you're doing here right now. You're going to come into a graphic and go, does this look normal? And if it doesn't, you have to go through each point and start to find out why it doesn't look normal. Okay, now I'm looking and I say, you know what, my outside air damper isn't right. It should be like 20 and 100, right? I'm going to try clicking down my control key and clicking on one of these values. All right, so whichever one I click on, it says, well, here's my economizer. My economizer is at 0, like right now, okay? And I can say if I want to go ahead and I want to lock my economizer open, all right? But what we're going to do with our economizer is we're going to go into the software and find out why it's not open. All right? So we're going to use a different method of troubleshooting. The first step was my return temp isn't right, and because I've used the system a little bit, I do understand that if my return temp isn't right, the unit believes that it's too cold and it may close my outside air dampers. We're going to go in and go find out why the outside air damper isn't open. We're going to use a different form of troubleshooting. Right? So I'm going to hit close. All right? And I'm going to go through my logic page. Right? My economizer. Telling my economizer to go open. Is this an input or an output? Output, obviously, right? We're going to send a signal and tell it to do something different, right? We know that it's the economizer damper. I just mentioned that if we go inside our logic page, we'll see that there's different boxes that help us separate the concepts of logic. This one is about the run conditions. Here's freeze stat, here's smoke detector, here's supply fan, here's cooling, heating, economizer control, right? So here I am down here, and I want to find out why. Why is my economizer at 0? Okay? This is the one nice thing about the logic page. The logic page is live. You're looking at the actual program running live. You saw me just click on my graphic, and it opened up a microblock. So now you guys know the graphic comes directly from the logic page, right? You saw me click the properties button and go looking for a schedule, and it opened a microblock. Comes from the logic page. Everything, your trends, comes from the logic page. Everything comes from this page, all right? So right here I want to find out. So all you have to do, because it's running live, right, is just read backwards. That's it, right? Everybody gets a book, and what do? We open the book, we read from left to right, we start at the beginning to get the whole idea of the story for the Big Bang at the end. We already know the Big Bang. We don't need to read the whole book, right? We know the return damper is not open. We know the economizer is closed. So all I got to do is just go find my section on my economizer and find my output, right? I know the economizer works off of an output. What does my output say it's doing? 0, right? It's an analog value. Dampers are either 0 all the way up to 100, right? This one says 0, right? And you see these yellow microblocks here? You'll notice that there's a little square in the middle. Looks like it's a different color. Those are animated, right? So all I have to do is just follow the wire and go down. If this was not made, you see how this one here, this switch, I come down here, you see how it's on? If this one was off, that would pop up. So I could literally look at my graphic page and follow the wire, all right? Just like if you had your meter and you're tracing power getting all the way out to your fan, you do the same thing here, right? If you have a piece of equipment that's not getting power, where do you start looking for it? Do you start looking for it at the electrical panel? No, you break out your meter, go to the unit, right? And you start going backwards and you just trace the wire, right? That same troubleshooting skill is the same one that we use here on the graphic page, all right? Mechanically, you go through and you find out where the power stops and then where it starts. We're going to do the same, right? It says 0. So I follow this little wire right through. I say, okay, it's going through. What does it say here? 0, right? I start coming through here and I see, what does this say? 20. And you say, no, that's funny. So this says 0. This says 20. I should at least see 20. But I could say it's not coming through. I could see another wire. What does this wire say? 0. So right now you're like, you know what? I've never read a logic page before. I have no idea what that means. So what? I see a 0 and I see a 20. It's doing nothing for me. But we have found the microblock where things are changing, right? It didn't take long to see 0, 20, 0. Why doesn't this 20 go through? Well, apparently they're all merging right here. So without a doubt, I know which microblock. Even though you've never looked at it before, you know which one to click on to start to look for your problem, all right? And here we go to go. We're going to take a look at this microblock, say, yep. And if I go back here, look, 20, 20, 20, 20, right? It's going all the way through. So right about here, that 20 is becoming a 0. Let's find out why. So you click on it and you go here. The limit is 0 and the input is 20. Well, if the limit is 0, what's the most you could put through? 0, right? The limit is 0. You're like, now why would I have a limit of 0? It doesn't make sense. All we gotta do is follow the logic again, right? You say, okay, well here, I see the 20's trying to get through. The input is 20. But it's saying, sorry, your limit is 0, so that's what you're getting. Right? So let's go ahead and we're gonna scroll through and find out, well, here's that 0. What is this 0 microblock? Well, I don't know. Let's take a look here. Right? I could keep clicking through. My input is 25. My output is 0. That's strange. Well, let me see. I could see here that from up to 40, I get a 0. From 45 up, I have 100. Well, from 40 to 45 must be everything in the middle. And I see it's 25. Where's 25 in here on the inputs? Less than 40, right? So if the output, right, 40 equals 0, 45 equals 100. Can we see why 25 equals 0? Let's go ahead and find out what that 25 is. All right, we come through here and I say, well, here, I could see this label. Now we're going to do something called chasing labels. Before, we used to have a wire that would go to every point, right? See the wire, see the wire, see the wire, right? It's going through. If we start taking these and start going to other sections, right, end up with wires all over the screen, right? It'd be very hard to follow. So ALC has given us these labels. Labels are just like wire nuts, right? When you have a 110 volt line and you want to add it to 2 places, what do? What's the label? What they've done is they said, you know what? To prevent you from having to put those wires all over the screen, it'd be impossible to find if they're crossing each other, right? They're all the same. And the only 2 wires on the screen are dotted lines, which are digital. They're either transmitting on or off. So if I see a dotted line in my logic page, I only expect to see the words on or off, right? Like a dry contact, it's either on or off. If I see a solid wire, I expect to see any value, right? It's analog. We could see that over here. It seems like here's the information. I looked at my microblock. It says the input is 25. Well, I see the output one that says 0, so this one must be the input, right? Inputs are always on the left. Outputs are always on the right. You get that, right? So you say, well, before what we used to have to do is we'd put in a label, and it says that as long as the label is spelled the exact same way, in the same case, it's like putting a wire nut on, right? So as long as it's spelled the same case, it's like the same thing. It's a wire nut. Now, they said, well, that was good, and they put it in there. They were very hard to find because you'd have to say, okay, I am looking for another label called MAT. And you scroll through and you read each one. All right? Takes a while, right? Well, they said, here, how about if we click on it and we show you all the instances? So here I get this window up here, and I see one red and one yellow. All right? Now, hopefully I'll find one, which I will if I choose run. Let me see, run. Here, 3 yellows and 1 red. You'll always have 1 red. The one that's red is the one that's talking. That's the one that's the 120 volt line, right? And all the yellow ones are all the extra wires that you're throwing in, right? They chose red, go figure. Can you figure out why they made red be the one that's talking? Huh? Because that's the hot one, right? That's the one where everything's coming from, right? The other 3 only work if that one actually has power, right? So 90% of the time when you come in, which one are you going to be looking for? The one that's talking. So they made it red. You're only going to have one. It's really easy to use. Then all you do is you click on the red one, right? And if you don't see it, there it is flashing right there. See? So here's the one that's flashing red, and then here's one that's flashing yellow. He's listening to the red one. Here's another one, wire nutted to this guy here. He's the one with the power. This is the one that's listening, right? Okay, let's go back to our MAT. Let's find out where that's coming from. So if I could click on it, I say, well, I can see this box is flashing yellow, so it's not the one talking, it's the one listening. Let me go ahead and see what it's wire nutted to. Well, here it is, the red one. All right? You got to look on your screen, you'll see it flashing. And I say, well, here, my mixed air temp, here it is here, right? Here's the red one. It's wire nutted to here. These two are connected, right? I could either do that, or else I could take a wire and I could come off of this mixed air temp like right about here, and I could put a wire across the screen, come up, go across these 2 wires, and put it in there, right? That would be a mess, wouldn't it? You couldn't follow it, so they did the thing with the labels. It's much faster, all right? So when I do this and I come down here, it says, well, here, my mixed air temp is 25. Well, right off the bat, I could tell you if my mixed air temperature is 25 degrees, I do want the outside air closed because something's wrong. I'm telling you, if my economizer says 0 on the outside air, right, 100% return, and I have a 25-degree mixed, I don't care what's happening, I'm telling you, those dampers are slipping. Something's open. My screen may say 0, but somewhere that actuator's lost grip of that rod, or the rod's broken, and that outside air damper's wide open, all right? So at least then I know I got to go to the unit because something slipped, all right, or something broke, something snapped. So what should my mixed air temp be normally? If I have a 70 degree, right, let's go ahead and say it's, 55 degrees. So my mixed air temp right now is 55 degrees.
Leave it locked.
And I'm going to lock it at 55.2, just because I wanted a decimal number in there. Now see how this changed here? Now look, let's go back. Let's follow this mixed air temp. And you say, well, I forgot where I was looking in the page. You say, you know, I got real lost. I was like all over it, and I know I came to the mixed air temp. Let's say, you know what, I'm going to go the other way. I'm going to click on mixed air temp. Going to find out where it's going. I see it flashing over here. Now I know where I was. All right, click on the micro block. Now, where does 55 now fall between these numbers? Above, right? So now my limit is probably higher now. I don't know, I'm just guessing. But now it says 100, and I come down here, and look, oh, my 20 is going through now. Let's look at this micro block. Well, the limit now is 100, and how much am I giving it? 20, right? So that's less than 100, so that's fine. And now my economizer is going in. What you just saw there, all right, this is called our mixed air temperature trap. This is inside all of your programs, all right? This is our mixed air temperature trap. And as we talk more tomorrow, you're going to understand that a lot of things could be going on over here, right? I could have this ramping up and down, trying to modulate to a temperature. Maybe it's moving too slow. Maybe I get a cold blast that's coming into the unit, right? So we put something in software that just simply says, in case somebody's locked something, in case a sensor isn't working right, no matter what happens, we've put in this software trap, and look how close it is to the output. The only other thing in this line is the freeze, right? So we put this software trap that says, just in case you see a low temperature because somebody's locked something somewhere else, we're going to go ahead and just limit it. That's it. Your limit now is 0. Whatever's going wrong, whatever the program's doing wrong, whatever you've locked, something is wrong, mixed air temperature is not safe, it's going to force it closed for you. All right? All right, so now let's go ahead and I'll take a look at my graphic, right? We're still going around. All right, did everybody get their return air temperature locked at some value? Probably in the 70s, okay. All right, so now here, my return air temp is 70 degrees. My outside air economizer now is opened up to 20 and 80, right? My filter, I don't have a filter alarm on here. My mixed air temperature is about 55 degrees. I'm not in a freeze condition. My supply fan says on and the status is on. My chill water valve, let's go ahead, we're gonna take a look at the chill water valve and the hot water valve. Let's find out, should they be open? I'm gonna go find, here's the chill water valve, here's the hot water valve. Should they be doing something? Let's take a look. You know, they're both getting zeros, right? I could follow the wire. Look, 0, 0, 0, right? See over here how the switch isn't on? We could come up here and we could turn. See, we just follow the wire, turn and go the other way. We can see that this microblock is saying 0. Well, we don't know what it is yet. But I want to show you something else. This has been included in all of your software for you guys. For the purpose of, right, you see the hot water valve and the chill water valve. We always want to make sure that safeties are in there, that the unit is safe as possible. So even though you can lock outputs, we've added these. If you look through, you're going to see on both of them, the manual overrides. Rather than locking the output right here, right, you can come inside here and say, here, I have 2 microblocks. You guys are going to try these, all right? I want you to lock your valve at 44%. All right, so here it is. That's my value, and it says here, lock on or off. Now watch this wire on here, okay? I'm going to turn on the lock over here, and watch that wire. See how it jumped down, and now you can just follow the wire, and you can see where it's coming from. The reason why we did this manual override, remember I just told you about those freeze conditions? Notice how if you use the manual override here, we still have to prove flow of the unit, so we'll make sure that we have flow. And then the freeze protection could still kick in, all right? You can still lock the output, just we need you guys to know that locking outputs is dangerous. If you're not staying focused on the air handler, it could be, the winner is when, of course, this will go wrong. When you could trip a freeze stat because you're keeping the valves closed, the hot water valve is shut, and the unit's cooling down, and you just forget about it, whatever the case may be. So we put this in here to try to keep that unit running. And then let's see here, I'm going to come down here and I'm going to come to my output just like I did on all the other ones, right? One of them I use the manual override. I'm going to do the same thing here, same way, 44. So I've locked it in both places. This one here I've used the manual override, and this one here I just did the point like we're normally doing. Notice how on the logic though, look, what does this show? 0, 0, 0, right? See how these all say 0? But then you come here, and I've overridden it, right? I've locked it to 44, right? So there's choices to make. You're saying here, is someone going to come in here and see all these zeros and think the valve is closed? Is someone going to forget to come over here and take a look to see if I've locked it? Because by doing this, I'm overriding all these values. See, it's saying 0, but I'm locking it at a value. So you can see why we have multiple places for you to lock it at. It depends on what you want to see, how long you're going to do it, what's the best way. There's a lot of different ways to lock values. And you guys are the ones that will be doing the locking. There's usually no other reason for like anybody else to be doing it. You guys are the ones that are going to be locking these points. You guys are the ones that are going to be reading trends, all right? So now let's go to take a look at our graphic. What do we have here? Oh, now look, my chill water and my hot water are 44% off it, all right?
Can't do that control and click on them and do it?
More cards, more cards, more cards. Here we go, more cards. Thanks. So I went through the logic page, and once again I could say, you know what, I don't remember where to do that, or else I want to check it. Once again, I'm holding down my control key, and I can click on this value, right? And now look, right, because I did 2 different methods. I don't see a lock, right? Because where is my lock really? It's 44, but there's no lock here. It's in the logic, right, under the manual override, okay? So that's one. So now let's go ahead and see. So now I can't do anything with it now. So now I know I got to go back into the program to go find it. Maybe that's something you say to each other that you don't want to do at the beginning. But keep in mind how this looks now. See, I don't see a lock, and it says present value 44. Unless I go through the system or go through the logic page, I won't know why it's getting 44, okay? But now let me take a look when I use the hot water valve. Now I'll click on the hot water valve. And now look, See, now I can see my lock. I could take this out. And I could say apply and leave it open, and now I'll see what the present value coming in is. Present value once is 0. See, and I had it locked. So there's choices to make on where you want to put the locks. So now to get the other one out, I got to go into software and do it. Okay? Or I could simply add a graphic, right? I could put something if I want. If you say, you know what, we do this a lot. You say, you know what, I'd like a button right here, a little dial that'll say on and off. We could do that. We could put an override button there. You could type in the value that you want. We could do anything we want with graphics. You just have to tell us what works best for you. This is a good place, the graphics, to get a real quick snapshot. Everything looks right except for that 44. It doesn't look right. And you say, here, I'm going to make sure it's not locked. I hold down my control key, I bring it up, and I go, here, it's not locked. Why is it 44 degrees? Well, once again, I'm going to end up back at the logic page. I know I have a chill water valve problem, so I'm going to go look for the section that has to deal with chill water. Well, that's not freeze stat. It's not smoke detector. Here, cooling control. And down here, I'll see the manual override is kicked in. So I'll say here, you know what, I'm just going to take the lock out. And just like the output, right, I told you, if that check mark isn't there, it doesn't care what the value says, right? I'm going to leave that 44. I'm going to turn off this lock, close this window, watch the graphic. See, now it pops up, it's listening to this line here, and this line says 0, and it's going through. See, it doesn't care what I have in the 44. It says, if you're not locked, then I don't care what value you want it locked to. Let's look at this output for the chill water valve, right? See, it's grayed out. I could come in here and I can lock it and say, here, lock it at 99. Fine. If I hit this, now it's interested in it. It says, okay, I'm going to follow it. If I take this lock out, right, it says, I don't care what's in the box. I'm just going to gray it out. It's not important to me. If you're not saying lock it, then I don't care anything about it. And if I come here, I'll see the actual value. See, look, they both turn to 0. Okay, so now I could go ahead, I could check my trend, and now things will look even better. Here I go back to this gym heating cooling. All right, then here's my sections. Here you go, supply fan status, my cooling, my heating. And I'm like, you know what, I have that supply fan status up here. I have it at the bottom. My mixed and my return air temperatures are in there. You know, I'm kind of looking at this unit going, well, I guess it's okay. You know, it's not great. You know, I mean, I get the idea of what's going on with the unit. Maybe I could remake my trend in such a way that it's the same as the air handler. You know what I'm going to do? I'm going to start over. I'm just going to delete stuff. I'm going to come inside here and I'm going to delete these points. All right. What's the first thing that we read when we were checking out our air handler to make sure it was okay? Turn air temp, right? And then we looked at economizer position. Let's go ahead and set up this trend in such a way that it matches the flow through the unit. All right. So I get 4 points and 4 graphs. Well, I'm probably going to run out of points, but I'm going to get them all in there. So the first thing I looked at was return air temp. The next thing that I looked at was economizer. All right. What did I look at after that? Mixed air. There we go. Mixed air temp, right? Mixed air temp. Okay, next from the mixed air temp, was I checking the free stat? The free stat was fine, wasn't it? I don't see it on there. Well, we're going to have to deal with that in a little bit. I'm going to leave a spot because I'm not seeing freeze on here, right? So let me go ahead and just start a new graph. All right, so I just based my decision. I said I'm going to track so many points. I'm not just going to choose which graphs they go on. I'm just going to use my points one after another. I know I can make 4 graphs. I could have 4 points on each. It's 16 inputs. I am just going to lay out my inputs the way that the air travels through the unit, and I'm going to look at a trend, and I'm going to see how it's going. All right, what's next after that? Mixed air temp, then freeze. Then wasn't it supply fan? I think it was supply fan start stop. Anyone looking on your graphic on your page? Then I'm going to add what? Supply fan start stop status. Chill water valve? Yes, chill water valve, then heating valve, then smoke. All right. Now I'm going to look at the chill water valve. Right? Then I'm going to add my heating valve. And look at that. I don't have my heating valve on here. It's another problem. I may have to leave some room for that and fix that problem. Well, then you know what? I'm going to delete this for now, and then I'm going to add another graph. What comes after that? Supply fan, or let me see, it was smoke, right? Smoke's not in there either. Okay, I'm going to have to fix that. Well, I say, you know what, here, this looks good. I'm going to delete that graph. I'm going to go and I'm going to check this out. Well, there's my return temp. I could see it was coming in higher, as it's supposed to. Then by the time it hits the mixed temp, it's supposed to be even less than that. When I hit the mixed air, right, well, here you have a return. Then we have the economizer damper position, and we can see that my mixed air temp is lower. This is the way that it should be. I can see that my, here's my on-offs. Notice over here now, look, I have analog values on the left. I have digital values on the right. Let's see what was happening like right around here. Let me zoom in. Here we go. What's the red one? My cooling valve went full open. My supply fan status here was, let me see, it says on. Look, see, right, it says on. My supply fan start stop is the yellow line. See, it says on down here. Okay. But you know what? I still don't like the trend. What did we forget to put in there? Anybody want to take a guess? What did we forget to put in? I checked all my temperatures, what they were. Didn't I really truly forget what they were supposed to be? Huh? Forgot to name them. But what was it that I was renaming yesterday? Heating, cooling, set point. So great, I have my temperature, I know what it was, but I forgot to add in what it was supposed to be. So I'm going to delete it again, I'm going to start over. Let's try this again. Let's go to configure, I'm going to delete my other graph, I'm going to go back to the first one, I'm going to delete my values. Okay, return air temp, and I'm going to add more points. Is there return air set point? No. Okay, what came next? Economizer. I'm going to add that in. Was there an economizer set point I was looking for? Well, here's economizer set point. I'm going to add that in. All right, next. I'm going to add another graph. What was my next graph? After I came around there, right, I had mixed air temp set point. Wasn't it the supply fan? I'm going to add my supply fan, start, stop. Then I want to know if it did start. All right, what came after supply fan status? Was the chill water valve, right? Here, I'm going to add another graph. Now, I need cooling set point. All right. I needed my mixed air temp. I have my mixed air temp on my last one, right? My cooling set point. My chill water valve will be next. What was my valve doing based on my set point? Great. What if I add another graph? Because I know after that is heating. I don't have my hot water valve, so I'm going to add my heating set point for now. I'm going to say, okay, view. And now we just built the trend that tracks the air as it's passing through the air handler. So now if I see a problem with one section on it, I could say here, I see the problem happening right here, right? I could say it looks, it looks wrong, like right about here. I could zoom in, and now everything will zoom in, and I can be looking at everything that happened. So yes, I can look at a graphic and see what's going wrong, like right now. Somebody tells me there was a problem with the unit. It happened about an hour ago, 2 hours ago. If I have this trend set up in such a way that I could track the air all the way through, track it in the order that the air handler is running it, I could just come here and zoom in and look at what happened right at that time. And I could say, well, it looks like the fan status went off and all my valves closed. And then suddenly it came back. Well, now I know that a current sensor is starting to go out, right? So I'll show you up here. So now that would be exactly what would happen. So what you just did right there, you're saying, well, how can I move around the trend, right? Because that's what's going to happen. Somebody's going to say it wasn't acting right. So you're going to want to look at it really close. Remember what I said about the resolution. We want to look at it really close, and then we want to see what happened. And then this was the way to do it. So I could use either the page up key on my keyboard or the page down. If I use the page up, see, I start to step farther and farther back from it, right? If I use the page down, I start looking in closer and closer and closer, right? But eventually I see my problem was all the way to the left, right? What I'm looking for is over here. I want to see this, whatever's going on here. I start hitting page down, I zoom in. Well, now you have your arrow keys, your left arrow and your right arrow. I could use my left arrow, start tapping it, I can go through. I can hold it down, it'll go through. Oop, I just saw it go by, right? If I lose it, I can always go back. All right, see where it's at. Let's try to do it a little bit slower. So here I am, I want to see what's going on with this section right about here. So I'm going to do page down. Now I see it's gone. I know it's to the left. Now I'm going to start moving to the left. I'm going to do page down again. Page down again. Now I'm using my left arrow, and I'm kind of going left and right. See, I can see over here where it turned off, and I can see here where it turned on, right? So now that's about as close as I could get where I could kind of keep track of it. Now I can see that my heating set point, right, when it went on, all during that time, right, from 4:10 to 5 o'clock. So for 50 minutes, that temperature started to go up, right? So you could use your keys to zoom in on your problem. Same thing here. I'm going to show you what I just showed him on his keyboard. So now, even when you're in here, you can say, you know what, I see this problem here on this temperature, and I just showed you how I can move left or right. Notice how all the times follow each other, right? I'm moving left and right. But I say, you know what, I want to scroll up and down. Well, what if I scroll like up or down? I don't want graphs to disappear, and that's not what's going to happen anyway. I'm going to specify that I want to look at my top graph, and I want to zoom up and down. So now I click anywhere in this top graph, right? Anywhere I want. And now look when I go up or down. See, it's the only one that's changing. See, it says, okay, you want to zoom up or down on this one. And then I want to go left and right again, right? And then I want to scroll down and I want to find my temperatures. Then I want to scroll like left and right. Page down, I start to zoom in more. Now I notice I only have one line left. See, now I can zoom in. See, now I'm scrolling up and down because I selected that one. See, now I can see each temperature as it comes in. Learning how to use trends is key. Learning how to maneuver around it. There you go, right? Zooming in, zooming out, selecting which graph you want to scroll up and down through. This is a huge benefit because all I'm doing is I know of a problem that happened at X time a little while ago, and I'm going to keep zooming in. I'm going to scroll in. I'm going to compare my temperatures. I'm going to zoom in more, move left and right. I am going to zero in tighter and tighter, right? And then once I get there, remember, you have your control key now. And I can click. If I hold down my control and I start clicking on the lines, I'll start getting my values. Show me exactly what it was doing at that time. All right? And of course, the closer line that I click to, that's the one it thinks that I want, and it starts snapping to it, right? It'll show me exactly what the points were. And then once I click off, see, so once you're zoomed in, now you can actually click on it and see the actual number, the actual moment, the actual time when it went into that value. Right, so I'm going to go to your building, and I'm going to look at your gym unit, right, because you're just calling me and you're telling me that something's going wrong with your freeze stat. I come to the graphic and I say, yep, you're right, I can see it's in a freeze. And I say, well, let me see, it's 70 degrees, it's 100 here, right, so the outside air damper's closed because we're in a freeze, 55-degree mixed. I don't know what's up with the freeze. If I wanted to, I could hold my control key again and I could click on this freeze. And I can see that nothing's coming up. So you could try that on your screen. Hold down your control key and try to click in that area, and you'll find that nothing happens. Because we've just written a code on here that says to watch from somewhere else. So I know I got to go to logic. All right? Is freeze an input or an output? It's an input. We're reading if the freeze stat is tripped. So we got to look down the left side of the screen. Here's the freeze stat. Look, your freeze stat is on. Why is the freeze stat on? Because it's cold out. Look at that. It is. Is it locked? No, right? I could come here and I could see that it's input 3. Right? We're going to talk more about this later. I'm just showing you. We're going to understand inputs and everything else. I want to get you guys used to just seeing the locks. Notice all the things that we're doing. Our locks are only on the summary page. On every microblock that you've been going through, there's a details tab. So there's a lot more that you could do. We just want to step through it real nice and easy. So when I come here, I can say, well, it does have a number. It's input 3. At this point, of course, I have to go to the unit and go find out if the freeze stat is tripped. On his, I know it's input 3. I'm going to walk up to his module over here, and I'm going to look at input 3, and I'm going to find out what it's on. Uh-oh. 1, 2, and look at input 3. Well, there's a paper clip in there. Oh, so we can see his freeze stats going off. So we should probably get him a screwdriver. He should get that paper clip out of there, and I bet you his freeze stat will clear. Now, I know that I've copied this already yesterday, and I've copied it out. And once again, sending trends out is very easy. Deleting many of them at one time, that's a huge problem. But here, I've just edited this out again. I have not changed its name, right? If I go to configure, right? If you notice, I could change this one, but notice the one that's in brackets. That's the one that's not going to change. Once it's in there, it just stays in there. So now I'm going to do my copy again, right? Because I really like this new trend. I think it's going to work out a lot better. All right, and I'm going to say here, copy this trend again. I'm going to say search all the buildings. Say apply, there it is. It's finding all the RTUs in your buildings. All right. There you go. See, so now here it goes. It goes from return to economizer, right? Then cooling and heating, right? So if you guys go in and you say, you know what, I made this trend, but I really didn't know how to make them a lot at the beginning, and now I made a really cool one, and I want to get it to go throughout the whole system. You don't have to go and delete everything. You can just edit the one that you have. All right? So if you feel like you could improve on your trend, you can make it better, you have a problem, and you say, if my trends were ordered in this order, it would have caught my attention quicker, go ahead, change that order. Do a manual copy, send them all out again. Keep improving your trends. Okay, we're going to start talking about logic a little bit, unless we want to make sure we got all of our trends, right? How are we doing on trending? We have to do it all over again anyway, but I want to make sure that, because the next time we go do it, I'm just going to call off which piece of equipment, I'm going to call off the points you're going to add, I'm going to tell you which graph they're going to be on, I'm going to tell you that I want it displayed only in 2 hours, not over a whole day. And then we want to do a copy paste, and we're going to check to make sure that they're all done. So that's reloaded. So now, when I was building my trend, I said, you know what? I said, I'm missing a few things, right? I'm missing, some of my other points. And if we remember, if we were looking in the book at the time when we read the trends, it said note. It says the only things that are going to be in the trees are trends that are active, right? Remember seeing that?